In our today's lesson, we're going to consider how to obtain the solution of given simultaneous linear equations involving two variables. So this is an example of a simultaneous equation that involves two variables, and we are to obtain a particular values of x and y that will satisfy this equation. That is, we are to obtain a unique value of x and y that will satisfy both equation 1 as well as equation 2. Now, there are so many methods we can use to obtain the solution of equations such as this. One of such methods is substitution method. Other methods include elimination method. But this video, I'm going to focus on how to make use of substitution method to solve equations such as this. Then in my subsequent video, I'm going to use elimination method to solve equations that resembles this one. Now, I have itemized 5 major steps that you need to take whenever you wish to solve a given simultaneous linear equation by way of substitution. The first step you need to take is to make one variable the subject in one equation. So what this means is I have to choose to make one of the variables in either equation 1 or equation 2 the subject. So I can decide to make x the subject in equation 1, or I can also decide to make y the subject in equation 1. Now, having said that, or having done that, the next step you take is to substitute what you have obtained in first step in the other equation. In other words, if I decide, for instance, to make y the subject in equation 1, then I will then substitute the value of y that I have obtained in equation 1. I will use it to replace this y here in equation 2. Now, if I do that, I will then solve the resulting one variable equation. What this means is that when I make y the subject in equation 1 and then replace the value of y here with what I have obtained in equation 1, I'm going to now obtain a linear equation in x, because by that time, I would have eliminated the variable y. And if I have then solved for the resulting one variable equation, I'll then substitute back the value of f that I will obtain in either of these equations to get the second variable, which is y. So let's see how we can solve this given linear simultaneous equation making use of these steps. First of all, I have to make one variable the subject. So suppose I choose to make y here, that is to make y in equation 1 the subject. I have to then subtract 5x from both sides of the equation, because equation 1 says that 5x plus 2y is exactly 14. Now, if I should subtract this 5x from both sides of the equation, I'll then have that 2y will be exactly 14 minus 5x. Now, I'll then divide both sides of this equation with the coefficient of y, which is 2. And if I do that, I'll then have that y is exactly 14 minus 5x divided by 2. Now, this means I can separate this, and I have that y is exactly 14 divided by 2 will give us 7 minus 5x divided by 2. So here I have isolated y, or I have made y to stand alone or to be in one side of the equation. Now I can decide to call this my equation 3. So based on the second step, I have to substitute this value here. Remember, we made y the subject in equation 1, so we are going to replace this y in equation 2 by this value. So substituting this value of x in equation 2, we then have that, remember equation 2 states that 3x minus 4y is equal to 24. So if I then replace this value now, I'll then have that 3x minus 4. So instead of y, I will now replace it by 7 minus 5x divided by 2. Then all this will give us 24. Now this will then imply that 3x minus 4 times 7 will give us 28. Then minus times minus will give us plus. Then 4 times 5x will give us 20x. Then 20x divided by 2 is exactly 10x. This will give us 24. Now, if I should collect like terms, 3x plus 10x will give us 13x minus 28 to be exactly 24. And if I should then add 28 to both sides of this equation, I'll then have that 13x is exactly 24 plus 28. And this will give us 8 plus 4, that will give us 12, that is 2. Then 2 plus 2 is 4, and then I'll have 52. Then if I should then divide both sides by the coefficient of x here, I'll then have that my x is exactly 52 divided by 13, and this is exactly 4. So we have obtained our value of x to be equals to 4. Now, we are going to substitute back this value of s in either of these equations. So here we already have equation 1, equation 2, we also have equation 3. So we are going to replace the values of s in either of these equations by 4 in order for us to obtain the possible values of y. Now, if we do that now, let us substitute it in equation 3. Equation 3 says that y is equals to 7 minus 5s divided by 2. And of course, you know that our s is now 4. So when we now replace this s here with this actual value 4, our y will then be 7 minus 5 multiplied by 4 divided by 2. And this is exactly 7 minus 5 times 4 is 20. 20 divided by 2 is 10. And so our y is equals to 7 minus 10, which is minus 3. So we have obtained our values of x and y that satisfy this equation to be 4 and minus 3. Now, if we should check by replacing the values of x and y here with this value of 4 and minus 3, we are going to see that here I'm going to have 4 here. That is, we're now going to have 5 times 4. This is 20. We're now going to have 2 times minus 3, which is going to give us minus 6. Then 20 minus 6 is exactly 14. And if we should also replace these values of s and y in equation 2 with this actual value, which is 4 and minus 3, then we're going to have 3 times 4, which is 12. Then we're also going to have minus 4 times minus 3 here. Minus 4 times minus 3 is also 12. Then 12 plus 12 is equals to 24, which shows that our value of s and y is correct. This is how we make use of substitution method to solve simultaneous linear equation involving two variables. Bye, and see you in my next lesson.